get started for the next one. Say your last few syllables of words. James is going to give us a little talk on observability and Kubernetes platforms. And James, I'm going to go over here.
All right. There's a quiz at the end, so make sure you got pencils. So I'm going to be talking about observability of Kubernetes platforms. I'm James Doherty. I'm a delivery consultant here at Arctiq. I guess I've been working, I think 15 years is a little optimistic. That's just trying to make me seem younger. But I've been doing design, deployment, operations of large-scale projects for a long time, a lot of different industries, and I like talking about observability. So what is observability? We used to call it monitoring, but now for some reason we like to talk about observability. I kind of see them as the same thing. Monitoring is more about focus on alerts, tell me what's not working. Observability is more talking about some data and tools that when I do get some of these alerts, I want to know, well, why did the alert go off? What was the impact? Or maybe I'm just doing some discovery. You know, what happens if I turn this knob in my cluster? I want to know, does it make it better? Does it make it worse? I'm not monitoring for alerts. I just want to see what happens. So they're not really that different, but I'd say they're more, chocolate and peanut butter. You start off with a little monitoring, and then you add some observability on top of it. There's really no hard line of, I'm doing monitoring, and then I hit a line, and now it's observability. It's really all part of a big spectrum. So in the old days, we had tools like Nagios and Zabbix and Graphite and Cacti, and they were trying to do it all. They were trying to do instrumentation, collect data, store it, analyze it, visualize. There wasn't a lot of great options for importing and exporting between the different tools. If the tool collected the data, that was probably the tool you were stuck in to do any sort of alerting or analysis or presentation. They didn't scale really great. And whenever you set up these monitoring pipelines, they were really static. It was really hard to change them after the fact. If you did, it was usually a big rigmarole, which didn't really work too great when containers started coming around. A lot of these tools are still used today. They are great tools, but they do run into issues. So then the cloud era came along, and one of the big things that I think drives observability today, the CNCF, they were, if you don't know who they are, they're a foundation that a bunch of industry leaders got together and said, they looked at problems like this and said, that would be really bad for containers, that if everybody kind of runs off and does their own thing, that's not going to work out so great. So they said, let's get together and try to be vendor agnostic and collaborate on some open source projects. Lots of projects, but I think the second one they came up with after Kubernetes, they brought in Prometheus, which is another open source system for monitoring, alerting, and a whole lot more. It's very widely adopted. If you haven't run into it yet, I'd be pretty surprised. Sorry, I have to fix my text here. So in Prometheus, you can collect and store data. It's got a great query language behind it. It comes with a bunch of client libraries. So for pushing and pulling into Kubernetes or into Prometheus, there's a lot of options. You can do alerting. It's a really great tool, and it's been around for quite a while. It's pretty baked in. And then kind of the dark horse is the OpenTelemetry project, which is a set of standardized SDKs, APIs, and tools for ingesting, transforming, and sending data to a backend. It doesn't have a backend. I've ran into this to a lot where people say, we're going to do OpenTelemetry, but they don't have a backend. They don't have anywhere to put all this wonderful data. OpenTelemetry doesn't provide that, but it does provide a framework where you can hook it up to a backend. Prometheus is one of the main backends for it. OpenTelemetry also works with logs and traces. Prometheus is just metrics. And then on the visualization side, Grafana's been around for years. It works really well with Prometheus. It's kind of the tool for visualizing data. So now we're in this great new era of observability. We've got common languages, protocols. We can instrument whatever we want. We can stitch our tools and data together as we need. We've got flexible collection pipelines. Everything's perfect. There's, presentation over, we're done. Of course, that's not the case. With all this, now that we've lowered the bar of how easy it is to get data into your monitoring and observability systems, now we've got zillions of metrics, and we don't really know their meaning or purpose a lot of the time. There's some pretty complex query language that you have to use to be able to get data out. It's really easy to create a query that seems pretty friendly and easy on the outset, but you've gone and created a query that's going to pull 10 billion metrics out of your back end. The tools are also kind of ignorant about topology and relationship between objects. The alerting's fairly basic. Every metric kind of stands on its own. There's no intelligence in there to know these are metrics about a pod that runs on a node that runs on a cluster. If I'm having problems on the cluster, that's why I'm having problems on the pod. There's no knowledge of that in these tools. There are other tools that do that, but you're not going to see that in Prometheus. So one of the big things to talk about with observability in the metric space is to talk about cardinality. If you're not familiar with the Prometheus data model, it looks a little bit different than what you might be used to. Usually you have a metric like CPU, you collect it from a host. There's not much to it. In Prometheus, they've got the concept of a data point has 4 pieces to it. There's the metric that you're collecting, like requests, the resource, the type of resource that you're collecting from, like a pod, and then you have labels. So I can collect requests by code. So tell me the number of requests I have that had code 200, code 201, code 404, code 427. So that count of values, that sum of label value pairs, represents the number of dimensions around a metric. So when someone says I'm collecting 100 metrics, it's not really, that could be 100 data points, or it could be 10 million data points, depending on how many dimensions those metrics have behind them. So if I do a little math here, if I have my fun dev environment with my single cluster and 10 namespaces in the cluster, 10 pods in each namespace, 1 container in each pod, and I am collecting a metric that has 10 dimensions, if I'm going to collect that metric at 1-minute intervals, it's actually going to work out to 10 million data points, which seems like a lot, but 10 million, 10 meg, not a big deal. But if I look in a production environment where I'm going to have potentially dozens of clusters, lots of namespaces, pods, containers, lots of dimensions to my metrics, what kind of potential cardinality am I going to see? Does anyone have a guess if you don't cheat and do the math? How big is? Yeah, it's going to be a trillion data points. For just collect a week's worth of data on a single metric across your entire environment, you've got 1 trillion data points. Now, in Prometheus, the average size of a data point is stored on disk is about 2 or 3 bytes, which is pretty good. But if you're collecting 1 trillion of them, that means you've got 1 trillion or 1 terabyte of storage required if you're going to store this one metric across this entire namespace. Now, this would be collecting a metric across every single container in your entire environment, which you probably wouldn't do, but it's something to think out for. And this is a problem that happens a lot in using observability tools, is that there's just so much data, and it's just so easy to collect huge amounts of data, and that's going to create some other problems for you. So I'm going to do a little walkthrough of a real-life example. Let's say, for observability purposes, I want to know the ratio of good and bad API requests for all my clusters. So the formula is I take the number of good requests and I take the number of bad requests and I divide them by each other. I'm going to use the API server request total metric, and then I have to look at the labels. I've got all my 400 and 500, they're definitely bad. 301, I'm going to count that as bad. 200 and 201, that's good. For some reason, 0 shows up. I don't know how you get a return code a 0, but I'm going to count that one bad as well because I don't know why it's happening. So if I do the math, the cardinality on that metric is 195. if I want to collect it for a week, it's going to work out to 1.9 million data points and to process or to store. And if I'm going to present it as a request across all my clusters, to pull those 1.9 million data points, I end up with 50,000 on my front end that I'm trying to display. So that's not too bad. A bigger one might be, let's say I want to know across all my, on a per namespace basis, across all my clusters, what's the CPU request utilization for 7 days at 1 minute granularity. So I've got 5 clusters, 25 namespaces per cluster, 100 pods per namespace, 5 containers per pod. I really like sidecars. And I've got a cardinality on that one of 62,500. Now I'm processing over 1 billion points of data, and then bringing back over 1 million points of data that I'm going to give to my front end and say, please display 1 million points of data for me. So if you've ever been using one of these tools and it's kind of slow, that's probably why. So now I think I'm about 14 slides in. I should probably talk about the actual subject of the presentation. So for platform observability, I'm talking about monitoring the actual platform itself. A lot of Kubernetes tools around monitoring, they're focused on the workloads that you're putting on top of the cluster. But if I'm a platform administrator, I actually care about, I don't really worry too much about what my silly developers are putting on there. I want to know, how is my platform doing? So I need good visibility of the core functions of the platform. I want to be able to drill down as I need it, and I want the UI to be responsive. When I'm talking about core functions, what are Kubernetes platform's reason for existence? They're there to maintain the life cycle of your containers, create pods, scale up, scale down, and provide resources to those pods and network access. What are the key components of your cluster? You've got the nodes, you've got your storage backend, and then you've got your control plane components. So those are kind of the key features of what you're going to be looking at. So where do you start? Later on, I'm going to do a little demo. I'm using GKE. They provide a lot of out-of-the-box dashboards and functionality for you. The first thing you have to do, though, is you have to actually enable the metrics. Surprisingly, they don't come out of the box a lot of the time, depending on who you're using for your Kubernetes provider. So you actually have to enable it and say, actually, I do want to see my control plane metrics. This is a little bit of Terraform in the resource for GKE clusters. You have to specify that you want those metrics. You start with the golden signals. That's latency, traffic, errors, saturation. Each control plane component has a purpose. So you want to focus on metrics that tell you how well is it serving that purpose. Your default UI, that if you're going to give someone a screen to look at, you don't want the first thing they see to be 10 million data points or 10 billion data points being displayed. You want a nice high-level, cluster-level view, and then provide some filters and groups so they can drill down to specific clusters, specific nodes, namespaces, that sort of thing. I've listed off some high-value metrics here to start with, and these kind of give you that golden signal view of your cluster. But once you've done that, the next step is to drill deeper. There's a lot of metrics in Kubernetes that are really useful when you're doing troubleshooting as to why are things not working. Your monitoring is going to tell you, hey, your API server, it's really slow. The responses are slow. By using the different labels available to you, you can dig deeper and to see, well, what's slow? Obviously not all the requests, maybe some of the requests. Maybe if I break it out by verb, I'll see that it's actually patches that are really slow. Everything else is fine. Or maybe it's only patches when I'm patching a cluster role for some reason is really slow. By knowing what labels you have available, it can help you in your tracking down a problem. There's also a lot of extra metrics that maybe you wouldn't put on the dashboard you look at regularly, but when you're focusing on an issue, maybe you're going to look at how much time is spent in your mission webhook. Maybe that's the reason that it takes so long for pods to deploy. This was generated by AI. pretty proud of it. It's an excellent pun. High cardinality. Yeah. I'm glad people got that. Yeah. Thank you. So when you're doing observability for Kubernetes, you have to control cardinality. It can get out of hand really fast. So on your back end, your Prometheus or whatever you're using as a back end, your concerns are resource costs. So your storage, your CPU, memory disk. It is very easy, except if you're using a managed service provider, you can end up eating thousands of dollars of cost per month on your back end just because you've ingested so many metrics. And you want your query performance to be reasonable. On the front end, it's UI performance. You want your front end to be fast and responsive. Again, that's in the hands of how much data are you pulling back in whatever screens you're providing. The way you mitigate on the back end is you have to monitor your monitoring. Yes, sir.
I wanted to check this high cardinality and concern for it.
Yeah.
I think you're saying it's fairly universal, whether you're using Prometheus and Grafana or some other platform too. Is that right?
Every platform suffers from that problem.
Yeah.
I'm going to be showing a demo on GKE, and the way that they've attacked this problem is they curated the metrics that are available to you by default, but there are still lots of ways to shoot yourself in the foot by enabling things like on the sidecars, that if you're doing a service mesh and you say, I need to know information about how my service mesh is doing, I consider the mesh sidecar, the Istio Envoy proxy, as part of my control plane. I need to start collecting metrics on that. That's where you start collecting metrics per pod. There's a lot of metrics. If you just say collect them all, you're going to end up with a cardinality problem.
Right. And that happens in every platform.
Yep.
And I think some platforms may try to address that through sampling rather than collecting all metrics.
For usually the sampling would be in traces, that you might not trace every single transaction that goes through the system. Maybe you're going to trace 1% of them. For metrics, it's usually they don't collect all the metrics. They collect 5 out of the 100, but they're going to collect them all the time. There's not really a metric sampling kind of thing. Where was I? Oh, so you always have to kind of monitor your monitoring to make sure you're collecting what you think you're collecting. Kubernetes changes all the time. They're always adding new things. Sometimes you can get surprised by a new version of your favorite CRD introduces a controller that suddenly starts broadcasting out a bazillion metrics. So you have to be kind of on alert for that. Of your control plane components, Kubernetes provides stable beta and alpha metrics like all their other features. The stable ones are typically safe to collect. The other ones can be a little bit riskier. There could be more than you expect. Also, when you are setting up scraping, in kind of older Prometheus setup, you could just say, I want you to collect any pod that has a scrape me annotation, start collecting his metrics. And what I would see is everything was great for a while, and then somebody thought, hey, this Prometheus thing is great. I'm going to add it to my pods. I'm going to deploy, I'm just going to change an annotation. And by changing that annotation, Prometheus sees, oh, I've got new metrics to collect, and apparently I collect them all, and it's going to do that, and it's going to pull back, 10,000 metrics from every single container. So, kind of have to keep an eye on that. Reading is really important for this. There's a lot of reference material out there on what are all these metrics, what do they mean. Some of them can be a little bit baffling as to what is going on. You have to do a lot of reading, and you kind of have to keep on top of it. One of our partners, Systeg, they are great at making blog posts to talk about metrics, what's important, why you should be looking at. I highly recommend checking them out. So now I'm going to do a quick little demo. Hopefully. Let me get it up here. That's not what I want. That's the same thing I just had up. It's getting worse. That's slightly better. Let's see if I can. Okay, excellent. So I've deployed some clusters in GKE. This is just a really small environment. There's 3 clusters with 3 nodes apiece. If you enable all these features, one of the great things that Google provides you is a great high-level dashboard for your clusters, picking off some of the important metrics that I talked about before, so you don't have to build anything. This is good for monitoring. They're not meant for, you can't say, oh, I want to see this label of this particular metric in this screen. That's not where that happens. If I go over to, I created another, where are you? Nope. Right, here we are. So I'll give an example of a high cardinality dashboard. This is the one. You. I'm old. This is the guy I want, I think. So this would be a high cardinality dashboard. And this is a problem I see with a lot of tools. Their default views are very high cardinality. They're showing you per pod, per container metrics. And usually not a big problem in a small environment, but as soon as you put this dashboard against a big environment, you're going to have all sorts of problems. So this is bad. I don't like this. This is just an hour. If we change it to, 2 days, it's been pretty quick. That's not too bad. But I don't have a large environment. I probably have 30 or 40 pods across my entire environment. So you can imagine if you had hundreds, this is going to be a problem. So not great. If I look at a little dashboard of the Kube API server, this is normally how, I wouldn't do this as a dashboard, but I kind of use this functionality of the grouping. So API server requests, this is across all 3 of my clusters, but I have the tools, I have the technology to say, oh God, this is hard to do. Where's my scroll bar? I should be just of course, it's at the bottom, and it's not sorted by alphabetically. Is it?
Is it other than network tier? That's the.
Oh, I can't see the screen from here. Anyway, I could say group it by cluster. Okay, you can go away now.
I think you can type cluster.
Oh no! Wait. Wait.
That always works.
Oh. Now I've done it. Oh, they were having an outage today in Europe. I kept getting. Killed it. I killed it. All right, that's okay. We'll just ignore that guy. We'll come back over here. This is what I want. I just won't do that again. That's not, nope, that's good, but thank you. So this is an example of, if you look at it by just API server requests across all types of requests, and then I might want to break it out by verb. So I can see here that most of my requests are gets followed by puts, posts. If I was digging into, why am I so slow? I come down here and I can see that my request time is 0.05 seconds. Pretty good. But one of the things I found interesting is, here's all my by verb. They're all very low except for one is watch, which runs once a minute, runs for a minute. So this watch metric brings up the average kind of in a way that's misleading, and you kind of have to say, oh well, I don't really care about watch. So I'll come over here and say that I want to add a filter and label verb. Does not equal. Of course, watch is on the bottom. And say done. Has to think about that. Right. So what I would use these kind of tools in, if I did have a problem with my API server, I would come to, there's an Explorer screen here where I would just start looking around. If I can't figure out what the problem is, come back to the metrics and try to pinpoint, is it a particular type of request? Is it a particular resource that's giving me problems? Is it my webhook, that sort of thing. Okay, I've jabbered on for quite a while. So are there any questions or anything that anyone wants to bring up?
Or maybe it's not really a question, but I have an anecdote for the high cardinality and how big you can get the data. I put observability tools on my home server a while ago, and I was like, I have like a 12 containers on this. It's really small, but I enabled everything, metrics, like traces and logs on the control plane, and I think I got about 60 gig a month of data coming in for like a small home server of 12 pods.
Yeah, it can happen. We had a customer who they had already enabled monitoring and everything was fine, and then they turned on service mesh. Oh, it came in. It's back. So now that we've excluded out the watch, you can see the difference between the different verbs. So even though the average is 0.05, we can see that, there's list up here at 0.2, that sort of thing. But we had a customer that, they had Prometheus enabled. What was wrong with that one? Oh, I talked it to death. They enabled. They had monitoring enabled, but they had scraping to just scrape whatever, and they enabled service mesh, and they ended up with, they went from having a cloud monitoring bill of, $20, $30 to $1,500 in the course of like a day, and it just, it can just happen that easily. So it's definitely something to watch out for.
I think I had traffic mesh on there.
Yeah, definitely. There's like so many metrics that come out of service mesh because they want you to, you can really dig into. I want to know every little piece of information about every transaction.
And I have connected traces through there too, so I have every trace for everything, including the control plane, which was pretty bad.
Yeah, I only looked at the metrics here. Obviously, for full observability, traces and logs are the kind of the next piece, but metrics are easier to talk about, I found. All right, that's it. Thanks for coming.